point, we have two different ways of calculating the area of a region. We have one using vertical slicing and one using horizontal slicing. I'll recap the two and then we'll do examples and see which one to use on which region. So let me put everything about vertical slicing on this first board, everything about horizontal slicing on the second one. So first of all, the picture is slightly different. In this case, the curve are given as y equals f of x. That means if it's not exactly given to you that way, you need to first isolate y to use this method. On this side, the curves are given to you as x equal. Again, if they're not given to you that way and you want to use horizontal slicing, that's still possible, but you need to isolate x. So curve is x equal, let's say h of y, x equals j of y. And so that means the two regions look slightly differently. In this case, you have x as your variable, so it goes from a to b. Then you have a curve above, a curve below. So let's say y equals f of x. Y equals g of x. And then the region is everything in between. On the other side, you have x equal. That means the curves are going like this. So I would have x equals h of y. I would have x equals j of y. And the region is between the two. So in this case, the variable is y, so you need to know the bounds for y, so let me put them here. You'll go from C to T. In the first case, we said the area was the integral from a to b of top minus bottom dx. And top minus bottom, you could see, is the area, the length of little sticks that I'll draw in green in this picture. All right, so that line has length, top minus bottom. It has width dx, so that's the area of one of these green slicing. And then you add them up with this fancy adding, which is called an integral, and you get the area. In this case, the reason why it's called horizontal slicing is instead of using vertical sticks, we're using horizontal sticks. So the green stick would look like this. Now its width is right minus left. Its height or thickness is a little infinitesimal change in y, so we call that dy. And because we have dy, the bounds must be for y, so the bounds should be from C to D. Alright, so how do you know which one to use? How do you know if I give you a region, I give you a bunch of curve, whether you should use vertical slicing or horizontal slicing? Well, there are two clues. Let me write them down. So if you give me or I give you, or we find a region and we want to compute its area, then there are two clues that you look for to determine whether you should use vertical or horizontal slicing. Clue number one was already on the board, but let's write it again because that's the most important one. Is how the curves look to you. If they're given to you as x equals something, then you should use horizontal. If they're given to you with y isolated, so y equals f of x, vertical. So curves are given as y equals f of x, then you should use vertical. X equals h of y, you should use horizontal. Now, if you choose not to follow that, what you do might be legal, but your first step would be to isolate one of the variable, and that algebraic step is not necessary. You could just use the other technique. The second clue is a bit more subtle. Once you sketch your region, looking at the sticks, you'll be able to tell whether you would need more than one integral to compute your region. So if top changes often, if bottom changes often, but right and left are always the same curve, then horizontal slicing would be better. If right and left keep changing, but top and bottom are always the same curve, then vertical